Hi, my name is Sam Eisner, and today I will be presenting on my CO2 sequestration project for Capstone Beta 2021. My goal in this project was to see if CO2 sequestration was noticeable on a small scale. I did this by taking a sensor that can detect CO2, give you the level of CO2, and store it in a database that I can later look at. I put that in a little capsule with a plant and minimal airflow. I also aim to learn about photosynthesis, respiration, and NRID technology, which is involved with the CO2 sensor. Now, why did I do this project and why should you care? Well, climate change is becoming a very relevant and serious issue that will affect all of us. So I think that this shows the impact that something as small as just getting a couple plants around your house can make. I hope to showcase that anyone can make a difference in this issue. Now, I think we can all guess that there is a pretty big difference in the CO2 produced to CO2 absorbed. But why is that? Well, the Earth naturally produces 750 gigatons of carbon dioxide each year, and that's okay. The problem is humans have come in and started adding to that number by 32.5 gigatons annually. This is what's creating such an imbalance, and this is why our planet is in danger. So carbon dioxide sequestering is the taking of this carbon dioxide out of the sky, out of the atmosphere, and storing it, kind of like a sponge. Carbon dioxide sequestering is currently known as the best method to reducing our carbon footprint and potentially saving our planet. Can anyone do it? Well, in a short answer, yes. Getting some plants requires very little materials and they can be very cheap. A lot of plants are very low maintenance, and they use photosynthesis and respiration to do the rest of the work for you. Well, how do photosynthesis and respiration sequester carbon? Photosynthesis takes carbon dioxide and energy from the sun and converts it to oxygen and glucose. Respiration is the opposite of that. It takes the oxygen and glucose and uses it to grow the plant, which releases carbon dioxide and water. These reactions are the backbone of the carbon cycle, which is necessary to all life as we know it. Will it make an impact? This is the question that I set out to answer at the beginning of this project, and to give you an answer, yes, it will. There is a noticeable variation of the carbon levels, also known as ppm or parts per million, over time. I used the CO2 sensor to record multiple tests over a week or so to see what would happen, and the data correlates with the photosynthesis and respiration cycle, as you can see on all these slides here. They all do a little bit curve upwards. That's respiration because it's releasing carbon dioxide, and then it comes down with photosynthesis as it's absorbing the carbon dioxide around it. You might have noticed that the day 3 and day 4 tests were done under direct light. This is because it is a known fact that photosynthesis performs better and more efficiently when it is in sunlight. So I wanted to see if putting the plant under direct light would make a difference in how the photosynthesis and respiration would act in terms of the carbon dioxide levels. This ended up not really making a difference, and I believe that is because the light that we put over top of it cannot really mimic the sun, as it is just way less bright. So what's next? What would I do if I were to start this project over or start where I left off? I think the first thing that I would do is test for longer intervals of time, leaving the CO2 sensor in the enclosure for a couple days, maybe a week, and look at the data after and see if there's any differences. I think the next thing I could do would be to create a bigger enclosure and put more plants in it, because I think that would be interesting to see if the difference would be documentable from one plant to maybe multiple. And one more thing that I could do would be to test a different method of sequestering carbon dioxide, because there are many. This is just the most common one. The example that I brought up on my slide is the carbon sink. It's just putting a bunch of carbon dioxide in water, in large bodies of water, and maybe I could test if that was documentable on a small scale. But yeah, thank you for listening. This was my Capstone Beta 2020-2021 project.